So just like we've been saying for the last couple of days, we have three forms of the quadratic: standard or general form, vertex form, and factored form, which is sometimes called intercept form. So you want to understand the important things that you can get from each. The standard form, general form, is the y-intercept, and it's just the c value. Vertex form obviously gives you the vertex, and the factored form gives us the intercepts, the x-intercepts. So what we started doing yesterday was changing forms, but when we tried to change from standard to vertex form, we got stuck. So we need a way to do that, and we're going to work on that today, and that way is called completing the square. So we're going to use algebra tiles. I have shared with you a Google drawing that has some algebra tiles, and hopefully that's going to work to slide those around and kind of see. I know it seems a little silly, but we're just going to do algebra tiles on the first few so you can get a visual of what this means, because I think it's super important to understand what we're doing. All right, so if we're looking to complete the square, it means I'm going to change a standard form into something that has a parentheses squared. So what we're going to do is look at these in terms of algebra tiles, where the big ones are x squared. I've got two colors just so you can kind of see what's going on. The long skinny ones are x's. And then these little tiny ones are ones. Okay, so if I'm trying to build this, I'm going to take an x squared, and then I need 6 of these. Okay, and the problem is that doesn't look very much like a square. It looks much more like a rectangle. So if we get rid of these here and instead bring in some down here, now we're creating more of a rectangular, or square shape. Okay, so I've built what I have said right here. I have x squared plus 6x. I want to know, what do I need to complete that square? So I think that's not what I wanted. If I start to drag these little ones, you can see that it's going to take 9 of them. I'll fill this in. Sorry. Okay, so what we have then is x squared plus 6x plus 9. If I think about that, that can be rewritten as x plus 3 times x plus 3, which is the same as saying x plus 3 squared. So when we talk about completing the square, we're trying to change from standard form into something that is a parenthesis squared. So what I would like you to do, I'm going to do the first one again with you. This is going to be on what you're doing. And so if I take an x squared, knowing what I know now that I'm trying to split the value here in the middle, trying to split it on either side. So I'm going to have 2x, so I'm going to have 1 on each side. I'm going to let you continue on this with your Google drawing that has algebra tiles. I'm going to have you take a look at this. You're going to arrange tiles so that they form a square and figure out how many of those the little tiny square tiles you need. and then write an expression as a trinomial. So here's the form you're going to fill out. You can maybe make one on your own paper and just fill these out, building these with your algebra tiles. Okay, then you're also going to answer these questions. So I would pause the video right here to answer these. And then I'm going to continue on, assuming you're back from the pause. You should have filled this out and gotten this. Okay, so I filled out how many tiles of the little tiny squares were needed in red. And then what I did was fill in the question mark with that value and then rewrote it as a perfect square. So the questions are, when beginning to form a square with the tiles, what do you notice about how the X tiles must be arranged? So hopefully you notice that it is a square that has half of, so you're multiplying half of it. So if I had 6, for example, I would have divided this into 1, 2, 3, 1, 2, 3. So my square ends up being a, right here with my 1, 2, 3, 1, 2, 3, 1, 2, 3, a 3 by 3 square. Okay, what is special about the numbers in the second column? Hopefully you saw that they were all perfect squares. How are the numbers in the second column related to the coefficient of the X term in each expression? So let's go back and look at that. So I'm saying, again, how are the numbers in the second column related to the coefficient of the X term? So here's what we're looking at. How is this related to this? Well, there it seems the same. But then if we keep looking, how is this related to this? How is this related to this? And the 9 related to that. So aren't we taking 1/2 of whatever we have here and then squaring it to get to that column in the middle? So if you went here and tried to do these, hopefully you saw that, and what you ended up doing was taking half of this, squaring it to get this, and then you saw when you rewrote this that that half ends up appearing in the parenthesis again. Okay, again, let me say that one more time. You take this, take half of it, and square it to get that. The half is going to end up in that parenthesis. Okay, so if I look at this, wouldn't this be b over 2? There's my half, and squaring it. So I would have here x squared plus bx, and I would say plus b over 2 squared, which is going to give me x plus the half here squared. And if I looked at what g would look like, I've got it sketched here, right? And so if you split the 5 in half, these are going to be a half. So when I try and total up how many I have, don't I have a whole one, a whole one, a whole one, a whole one? So I have 4 wholes. Then I have a half and a half, a half and a half. So doesn't that make 2 more? And then this little guy right here is going to be a half on one side here and a half on one side here. So if I multiply a half times a half, that is, whoops, let's just erase that to make it a little better. That is a fourth. So I would have x squared plus 5x plus 6.25. And I think if you check your chart, you'll see that is true. And this is x plus 2.5 squared. And hopefully you're all seeing that this number, when doubled, gives you that. So this is a times 2. And when you look over here, this is squaring it to get that.